Hi, I'm Lee Teschler, Executive Editor of Design World. What I have here on the end of my finger is a piece of carrier tape containing a 5-channel array of diodes that protects against electrostatic discharges. This particular device is from Littelfuse, and it's called the SP1012. It's designed to protect data lines from repetitive ESD strikes to levels specified in IEC 61000-4-2, the international standard for ESD protection. You can't really see much looking at the chip itself. We have a super close-up shot of the chip package so you can see it better, but the whole package measures less than a millimeter on a side, and each of the 6 pads for making solder connections measure a little less than 0.2 of a millimeter square. In other words, the chip by itself would look like a speck of dust. That's why I have 2 of them here on this piece of carrier tape. So for the rest of this short discussion, we're going to talk mainly in terms of the chip's schematic diagram. From the schematic, you'll see that the SP1012 contains 6 avalanche diodes with the anodes all common together. It's common practice in ESD chips to connect one of the chip terminals to ground and then connect each of the other 5 to points that need ESD protection. When you do that, it's easy to see what happens. In the case of a super high voltage spike, the avalanche diode connected to the data line will begin reverse conducting once it sees a voltage above the standoff voltage. For this chip, the nominal standoff voltage is about 6 volts. And when one of the diodes conduct in avalanche mode, the resulting current then conducts through the diode connected to the ground, which of course just behaves like an ordinary forward bias diode. There are a couple other parameters on the SP1012 series that are worth mentioning. ESD diodes are designed to clamp high voltages but at low energies. Specifically, the SP1012 handles a peak current of 3 amps for up to 20 microseconds. It clamps voltages to between 10 and 12 volts thanks partially to a dynamic resistance that's nominally about 0.48 ohms. Now, as a quick review, the dynamic resistance of a diode comes about because the diode's current versus voltage curve is nonlinear. Ohm's law still applies, of course, and resistance still equals voltage divided by current. But for a diode, the voltage-current characteristic is a curve, not a straight line. So diode resistance, R, is actually the change in voltage over the change in current. Literally, the diode resistance is the slope of the VI curve and depends on where on the curve you measure it, which is where the idea of dynamic resistance comes in. Because we're talking about avalanche diodes, the area of the VI curve where you're worried about dynamic resistance is that point around where the diode enters its avalanche mode. Just a few other points worth noting. This chip is in the same size package as an 0402 style chip, which has just 1 diode. So the SP1012 is super dense. It is also good for protecting more than just data lines. Micro SIM and micro SD interface cards, keypads, and signal lines on capacitive touchscreens are all good applications. To learn more about how the SP1012 series bidirectional TVS diode array can simplify your next circuit design, download the ESD Suppression Design Guide, available free from Littelfuse Speed to Design.